Hey guys, it's Ms. Martinez, and today we're going to be talking about scientific notation. So today's date is the 3rd, and then scientific notation is our topic, and my page number is page 17. Okay, so for our learning target today, we are going to convert standard to scientific notation. Scientific notation is our topic, and our essential question is, what is the process for converting between standard notation and scientific notation? So let's see what scientific notation is. So scientific notation is a shorthand way of writing a really big number or a really small number. Okay, so an example of a really big number is the mass of the Earth. So let's look at this number. This is the mass of the Earth right here in kilograms. The way you say this is 5 septillion 900 sextillion kilograms. Okay, there's a lot of zeros and nobody has time to write all those zeros, but you know. An example of a small number, but a long number, is the mass of an electron. We know electrons are really, really small. So if we look at 0.0, look at all those zeros. Look at all those. So no one has time to write all those zeros. So that's why they came up with scientific notation. So if we look at the mass of the Earth, the scientific notation of that big number is this right here. 5.9 times 10 to the power of 24. That's like a simple way of writing that huge number. Okay. Let's see the scientific notation of the mass of an electron. The way you write that big number is 9.109 times 10 to the negative 31st power. Okay. So before we do some practice, I want you guys to know this important information about scientific notation. Write these down, and then also try to remember them because they are very important. So the very first thing is it's always written as a product of two numbers. So if we look here, this is a number and this is a number. Product, we know is multiplication, which is right there, right? The times the multiplication. So it's always written as the product of two numbers. Okay. The other thing is the first number is in between 1 and 9. Okay, so let's look, oops, sorry. So the first number right here is 5. That's between 1 and 9, yeah. And the first number for the mass of electron is a 9. That is between 1 and 9. It's actually 9, right? So those are good to go, okay. The third thing is that the second number must be a 10 and with an exponent. So an example would be 10 to the power of negative 5, or 10 to the power of 2, or 10 to the power of 100, okay. In Earth's mass, the example for that one, the exponent was 24. That works as well, okay? So let's look at how to convert standards to scientific notation, okay? All right, so we'll have like 3 column notes on this one. First is create a number between 1 and 9 by moving the decimal. So let's say we have this number right here. Let's say we have 7,900,000, okay? We're going to move the decimal, and I know the decimal is right here, right? Because it's a whole number. And we're going to move it so that way when we move it, the first number is going to be between 1 and 9, okay? So let's move it over here, 1, 2, 3, 4, 5, 6. If we move it right here, the first number would be 7, and 7 is between 1 and 9. So that's where I'm going to leave my decimal, okay? The next thing is count the number of times you move the decimal, and this would be your exponent. So we moved it 1. So we moved it 1, 2, 3, 4, 5. We moved it 6 times. Okay, so that's going to be my decimal number, 6. Okay, but first I need to know whether it's going to be a positive 6 or a negative 6. Okay, so let's see what this says. Number 3 says, if your original number is greater than 1, then the exponent will be positive. So in this example, 7,900,000 is greater than 1, so that 6 will be a positive. So we're going to write 7.9 times 10 to the power of a positive 6. Okay, and that is the scientific notation of this number right here, the 7,900,000. Okay, let's see if our number was less than 1, so if it was a decimal, then the exponent would be negative. And let's look at an example for that of that. So let's say we have 0.00000095. Okay, we're going to move this decimal to, so that way we can make that first number be between 1 and 9. So I'm going to move it right here in between 9 and 5. Because if I move it over here, the first number would be 95, right? And that's not between 1 and 9. So it has to be between the 9 and the 5, not after it. Okay, so I know it's going to be 9.5 times 10, and let's see how many times we moved our decimal. We moved it 1, 2, 3, 4, 5, 6. We also moved it 6, but our original number was less than 1. It was a decimal, right? So it's not going to be positive 6, it's going to be negative 6. Okay, so it's going to be 9.5 times 10 to the negative 6. Okay. All right, so let's practice converting standard form to scientific form. Okay. So our first number is going to be 42,000. So if we look at 42,000, let's look at this decimal right here. We're going to put it right here, right? And we're going to move it 1, 2, 3, 4 times. So that way the first number is a 4, and that's between 1 and 9. So we can write it as 4.2. How many times do we move it? 1, 2, 3. We moved it 4 times. The original number is greater than 1, so it will be positive, right? So it will be 4.2 times 10 to the power of positive 4. Okay. Let's look at the next one. 5,820,000. So for that one, we have our decimal right here, and we're going to move it so that way the first number will be between 1 and 9. So 1, 2, 3, 4, 5, 6. We'll move it right here. Okay, so we got 5.8 times 10, and let's see, 1, 2, 3, 4, 5, 6. We moved it 6 times, and that 5 million number is bigger than 1, so that 6 is going to be positive as well. So the power of positive 6. Okay, go ahead and try this one on your own and pause the video. So hopefully you pause the video, and let's see what we get. So we have the decimal right here, and let's move it. I'm going to move it right here. I'm not going to move it in between 2 and 5, because 42 is not between 1 and 9. 4 is, though. So it's going to be 4.25 times 10, and let's see what power it is. 1, 2, 3, 4, 5 to the power of 5. 425,000 is greater than 1, so I know my exponent will be a positive 5. Okay, let's do the next one. We got 0.007825. This is a small number, right? So if it's a small number, if it's a decimal, then it's going to be a negative. Our exponent is going to be negative. So let's see what our exponent will be. If I move it 1, 2, 3, right here, that 7 will be my first number because it's between 1 and 9. So I'm going to write it as 7.825 times 10. Let's see how many times I move it. 1, 2, 3. I moved it 3 times, and it is a small number, so it's going to be a negative 3. Okay, and that is my answer for that one. And then the last one, try and see if you can do it on your own. Okay, so pause the video. Hopefully you pause the video. Let's see what we get. So our decimal is right here. Let's move it over. You should have moved it over to right there. So that way we have 9 times 10 to the power of 1, 2, 3, 4, 5. 5, but it's a small number. It's less than 1. So it's going to be a negative 5. Okay. All right. So if you do not have room for a summary, please make one. It can be like really short right here. Go ahead and write your summary. And the summary is answering the question, what is the process for converting standard notation to scientific? This was standard right here. And then this was scientific. I'm going to abbreviate scientific notation. Okay. All right, so let's highlight some of the important stuff here. So let's do a green. Yeah, let's do this green. Okay, so scientific notation, I want to know what that is and the definition. And then these right here. These are extremely important. Make sure you memorize these, or like, I mean, they're going to be easy to remember if you do the practice. Okay. Okay, so the other thing is that if the original number is greater than 1, it's going to be positive. And then if the original number is less than 1, so if it's a decimal, it's going to be a negative. Okay. All right, so if you have any questions over this, please come to your class period Teams meeting, and I can help you there, okay?